Academic, Monday, March 6th. We're going to do the 5.3 notes, okay? So let's get out our trig identity sheets, okay? So 5.1 and 5.2, the stuff that's going to be on the quiz, right? That was all about these first 8 identities right here. Okay, that was our jam. That was our jam for 5.1 and 5.2. Now in 5.3, we're going to move on and practice what are called we're going to move on to this part of our sheets. And these are called the sum difference identities, okay? Yeah. Yeah. It's next to Elise. Okay? So 5.3 is all about our sum and difference identities, okay? All right, hopefully you read my email. Mrs. Ford said, and I think so too, this stuff tends to not be as difficult as the first 2 lessons, okay? It's very formulaic. This is 5.3, yep, the 5.3 notes. Dang it, my cough went away yesterday and it came back now that I'm back at school. I think this room's just super dusty. Okay, so we're going to use it for this first problem here. Wait, is it still going? Okay, sorry. So find the exact value of sine 15 degrees, right? Why is this kind of tough? Why is this problem kind of tough? Why can we not do this with what we've learned so far?
15 degrees is not on the unit circle.
It's not on the unit circle. Yeah, it's not on our special triangles, right? It's not there. It's not there. Okay, so we've got our 30, 60, 90 triangle. We've got our 45, 45, 90 triangle. All right. Does anyone see 15 on here? Does anyone see an angle that we could use as a reference angle for 15 degrees? No. You're on the right track. You're absolutely on the right track. So we need to rewrite 15 using 2 of the angles that we do have on our right triangles. Okay? What's that? Yes, that's next section though. Jumping ahead. That's actually what I would have done here. But we're using the sum difference identities. So which 2 angles have a sum or difference of 15?
What are the sum difference ones?
The ones I just squigglied on the sheets. Right here. Those are the sum difference identities, those 6.
You can split screen the identity sheet and the other ability at the same time.
Awesome. Do I use this? Which button do I use?
What are the first identities called? Mr. Rusker?
So these, you can call them the reciprocal identities, if you want to. I don't know what these are called. It's just sine squared plus cosine squared equals 1. Yeah, you have the notes, Sammy?
What?
You have the notes?
Yeah, they're on that.
Okay. All right, just follow along on paper right now, okay?
Did it work?
Yeah. Let me try to switch. How do I switch that? Just follow along. Okay. Okay, good. All right, so we're going to rewrite this.
If not, you can just slide it over.
Okay. We're going to rewrite 15 as 45 minus 30 degrees. 45 degrees minus 30 degrees, okay? We do know both of those, right? Sine of 45, sine of 30, okay? And what I'm going to do here, oh gosh. Okay. I'm going to unsplit screen it, and I will work on that later. But thank you. I appreciate that. That will be helpful. Is I'm going to use an identity I have here for sine of u minus v, right? I want the formula for the sine of a difference of two angles, okay? The formula for a sine of a difference of two angles, okay? So you see that the third line down on that right column, okay? Sine of u minus v equals sine u cosine v minus cosine u sine v.
We have to memorize these too.
No. Although I recommend it. Actually, I just recommend whenever you see a sine or a cosine of a difference or sum to know that you have to. Those aren't as important to memorize as like these three are. And like these three. Okay.
Are we eventually gonna have to memorize all of that?
I don't think so. Mrs. White made it sound like we don't. Okay. So what's my u here? What's my u equal to? 45. What's my v equal to? 30. Yep.
Why do they choose like the most like they look the same? Yeah.
Letters.
Yeah.
Mathematicians just like doing that. Like P and Q. Sorry if you have dyslexia. I apologize. All right, so we're just going to plug it in those u and v's into the right side of this equation. So this is going to become sine of 45 degrees, right? U is equal to 45. Cosine of 30 degrees minus cosine of 45 degrees sine of 30 degrees. Okay. All right. All right, and then I do know how to evaluate these four numbers, right? What's the sine of 45 degrees?
1/32.
What's the cosine of 30 degrees? Adjacent over hypotenuse. Maybe root 3 over 2. What's the cosine of 45 degrees? 1 over root 2. And the sine of 30 degrees? 1/2. So there you go. That's our answer. Right there, we just need to do a little bit of simplifying, okay? So this becomes root 3 over 2 root 2 minus 1 over 2 root 2, which is root 3 minus 1 over 2 root 2. Rationalize. You get root 6 minus root 2 all over 4. There you go. That's the answer.
You can't subtract the two roots.
No, you cannot. You can multiply them or divide them. You can't add or subtract. So.
You just to rationalize it, you just do like root 2, not 0.
Yeah, you only need to do root 2. Yeah. If you did 2 root 2, you wouldn't get the wrong answer, though. Yeah.
Would we have gotten the same answer? Oh wait.
You would have had to if you did it correctly using another identity.
Yeah.
Yeah. Yeah, you would have had to. Bless you, bless you. If you didn't, there'd be a contradiction in math.
Would you have gotten the same answer if you used?
Half angle identity or double angle identity.
For example, on the next one, like 165, instead of doing 45 minus 30, what if you did like 45 plus 30? You got the same answer.
For number 1, that'll give you a different answer because 15 is not equal to 45 plus 30. You cannot write 15 as 30 plus 45. So that would have given you a different answer.
Okay, so I said that wrong. What I meant was, for like problem 2, like 165, if we did 45 plus, what is that, 120, would you get the same answer if you did 360 minus like 165?
Yeah. As long as the sum or difference is equal to your original angle, you get the same thing.
Okay.
It might be a harder way of doing it, but you'll get the same thing. Okay? All right.
Can you get 165?
What's that?
Can
Yeah, so now we got to figure out, so there aren't two angles on our special right triangles that add to 165. Yes.
So you do like 45 and 120.
You could do 45 and 120. Yep. You want to do that? Okay. So this becomes cosine of 45 degrees plus 120 degrees. So we have to, one of our terms, Allie, has to be something that's not on our right triangles, but something that we can get from like a reference angle on our right triangles. Okay? Does that make any sense?
So there's always has to be one that's not on our.
Not always, but there can be.
Oh. Okay.
Yeah, yeah. The 120? So I needed to rewrite 165 as the sum of two angles whose cosines I do know how to find. 45, right? So my 45 degree angles on this special right triangle. 120 is not on this special right triangle, but we can find it using 60 as a reference angle. Yeah. Using our T-sac right here. 360 degrees. 180 degrees. Okay. So 180 minus 60 is in the second quadrant here, so I can know that angle. Okay. Right, so cosine of 45 degrees plus 120 degrees. Okay, so that formula, that's going to give me, looking at my reference sheet, okay, the third line down, right here, I'm looking at this line right here. That's going to give me cosine of 45 degrees times the cosine of 120 degrees minus the sine, oh gosh, I'm out of room, sorry. I'll write this smaller. Minus the sine of 45 degrees times the sine of 120 degrees. Okay. Notice that when I use cosine, that the two sines, the two SIGNs are opposite. So it's a plus. It becomes a minus when I apply my formula, okay? All right? So that's it. That's all the trig identity stuff. Now we just have to evaluate these angles, okay? What's the cosine of 45 degrees? 1 over root 2. Cosine of 120 degrees. What reference angle do I use? What's that? We use 60. 60, right? So 120 degrees, right? It's in the S quadrant here. When I draw its bearing, it's in the S quadrant. 180 minus 120 is 60 degrees, right? So the cosine of 60 degrees is what? 1/2, right? And am I going to make that a negative or positive 1/2? Negative, yeah. So we're still using that last chapter, guys. What's the sine of 45 degrees? And then sine of 120, again, I'm still in the S quadrant. So my reference angle is still the exact same, right? 180 minus 120 is 60. What's the sine of 60 degrees? And do I need to make that a positive or a minus? Positive, yeah. Good job. Okay, so then simplifying, I get negative 1 over 2 root 2 minus root 3 over 2 root 2. Gives me negative. Here it does not.
I'm adding.
Yeah, if you're adding, if you're doing an addition identity, no.
You're subtracting.
If you're subtracting, it does, yeah. So over 2 root 2. Okay. Let's rationalize. So times root 2 over root 2. So we get negative root 2 minus root 6 all over 4. Yeah. Yeah. low battery. Yeah.
Can you explain why cos 120 was negative?
Why it was negative? So when I draw 120 degrees on my coordinate axes, which quadrant is my bearing in? It's in the S quadrant, right? S means that only sine is positive for angles in that quadrant. So that's why I was negative. Yeah, good question. Good. Can I move on? Tan 195. So what are two angles? 150, 80 and 15. We don't know how to find the tangent of 15. We could using something like this, but that'd be extra work. The best way to do this is tan of 150 plus 45. 150 plus 45. Okay? Right? 45 is in our right triangles, our special right triangles. 150, right? 150 is not in our special right triangles, but if I draw its bearing, this is the same thing. If I draw a bearing of 150 degrees, I end up in the S quadrant. And that gives me a reference angle of what? 30. Okay? So we'll have a positive sine, negative cosine, negative tangent for 150, okay? So using this tan, this formula right here, I can write out my answer, okay? So that's going to be tan, it's going to become tan 150 degrees plus tan 45 degrees on top. And on the bottom, it's going to become 1 minus tan 150 degrees times tan 45 degrees. So I'm plugging that 150 and that 45 into my formula, okay? This stuff's more formulaic. Right? Because it's a lot easier to decide which formula you're using. Okay? So 150 degrees. What's the tangent of 30 degrees? 1 over root 3, and that should that be negative or positive? Negative. What's the tangent of 45 degrees? 1. Tan 150 was... Okay. So simplifying the bottom a little bit. Right? 1 minus negative 1 over root 3 times 1 is the same as 1 plus 1 over root 3. Okay? And then I need to combine these two terms. Okay? So that 1 has a denominator of 1. Let's multiply the top and bottom by root 3 over root 3. Same thing down here, right? This won't cancel out. If you have a 1 minus and then a 1 plus, the same thing, those don't cancel out. They would cancel if like they were both minuses. Yeah, or if they were indeed both pluses. No, so if I rewrite this, I can rewrite this as 1 minus 1 over root 3 and 1 plus 1 over root 3. Those don't cancel in general. Yeah, I like the thinking though a lot. That's really good thinking. So that's going to become negative 1 over root 3 plus root 3 over root 3. Okay, so I'm not doing any trig at this point. I'm just trying to simplify my answer, okay? At this point, you would have gotten a lot of partial credit, at least, okay? So I'm just simplifying my answer. I'm getting common denominators on the top. So I have negative 1 plus root 3 over root 3.
Could you write that as root 3 minus 1?
Yeah. Yeah, I can do that real quick. Okay. just going to multiply the top and bottom by root 3. Get these to cancel.
Could you like? Could you just like multiply root 3 minus 1 over 3 times root 3 over root 3 plus 1? Like multiply by.
Oh, multiply that by the reciprocal? Yeah, that'll also give you the same answer. That's probably better for you guys, actually. Thank you. Yeah, so taking this fraction and dividing it by this fraction is the same as doing what? Multiplying by the reciprocal. So multiply by root 3. Root 3 plus these cancel. There you go. Thank you. I was like, I feel like there's a better way to show this. There you go. Yep. Chapter 6 of Algebra 2.
Are you good with the root 3 on the bottom?
Wait, can you like keep it there for a second?
Yeah. I don't know how to get rid of it.
You need to multiply by root 3 on
You multiply by root 3, but then you'd be left with a root 3 right here.
okay.
Yeah. Let's see what Miss White did. Yeah, she just left it like that. Yeah. So I'm okay with you leaving the root 3 in the bottom here just because there's a plus sign. Yeah, if it were like root 3 times 1, I would want you to rationalize it. Yes?
What if it's root 3 minus 1 over root 3 minus 1?
Then it'd just be 1. Unfortunately, we don't have that here. Okay. All right, and you guys want to do D real quick? All right, Miss White didn't do D, so we're not going to do it.
Are we gonna have one like that?
If I'm not doing it, I probably wouldn't give it to you.
Oh, if we were to do it, would you just do like 1 over secant and then like.
What I would do, yeah, I would change that to a 1 over sine, and then I'd add 360 to that angle, because I don't like working with negative angles. Yeah. Yeah. Office hours. That's a good office hours question. If you're just doing it for fun. Simplify. Sine 58 cosine 32 minus 32 cosine 58. So now we're going the opposite way around, okay? So those first 3 problems, I gave you, we're looking at the sum difference identities on our sheet, okay? We started with this left side here, and we rewrote it using the right side. Now we're going the opposite way. We're starting with the right side, and we're rewriting it using the left side of my equations. So which, on this problem here, which line on my identity sheet does this expression correspond to? Yeah. So this one here is the same, I guess, format of this problem, right? What would my u be equal to here? 58. And what's my v equal to? 32. So this expression equals sine of 58 minus 32 degrees. Okay? Which is what? Sine of 36? 26, sorry. So this is simplifies down to sine of 26 degrees. That's my answer, okay? So this stuff's a little better than 5.1 and 5.2. You guys okay with that?
Yeah.
So will you always come first?
Yeah, it does.
And then with sine, it's always like sine and cosine on both sides.
Yeah, yep, so you're seeing the pattern? Yep. You are seeing the pattern. Okay, what about this one? Look at my trig identity sheet. Look at those oh my gosh, I hate the way that ability does this. Look at these 6 on the right. Which trig formula, which trig identity does this expression correspond to? It's going to correspond to tan of u plus v. Okay. I figured that out. I figured that out in my head because, right, we know it's going to be a tangent, right? Because the problem gives us a fraction, right? They gave us a fraction in the problem, and they gave us a fraction with a plus sign on top, okay? Going to my trig identities worksheet. Gosh darn it. The only trig identity that has a fraction with a plus sign on top is tangent of u plus v. That's how I figured that out. It's the only fraction with a plus sign on top. Okay. So this is going to become, we're going to use tangent of u plus v. What's my u equal to here?
13.
What's my v equal to? 18. Okay, what's 13 plus 18? 31. Okay, so my answer is tangent of 31 degrees. Okay? Alright. All right, yeah.
I mean, you really need to do like all that because you just figure out that, like, if you look and just plug 13 and 18, just add those. But
If you can get that like in your head with less steps, do it. Yeah. I show like way more steps than you might need in class, just because I think that's easier. Yeah. Yeah. Okay. All right, let's do C. Cosine 12x, cosine 9x, minus sine 12x, sine 9x. Okay. So looking at my identity sheet, I'll use yours. Looking at my identity sheet, which one has two terms? Like there's two cosines on the left and two sines on the right, and they have a minus in between them.
that's not plus the
Yeah, cosine u plus v. Yep. Exactly. Okay. What's my u equal to here? 12x, right?
Yeah.
What's my v equal to? 9x. Okay. So then this is going to become cosine of 12x plus 9x, which is just 21x. There we go. Okay? That's okay? Nice. Let's go ahead and do D. No, I'm going to keep it till Wednesday. I'm going to have you guys turn it on Wednesday, just kind of as a little quiz review. Yeah, so this one, right, we've got two sines minus two cosines. Two sines minus two cosines. It's close. Yeah, so this one's a little different. You gotta do a little bit of trickery. Okay? So we've got one on here that's what? Yeah. We've got one on here that's two cosines minus two sines, right? How do we get one? There's nothing on here that's two sines minus two cosines, though, right? How do we force this to become that? How can we switch the sine u and sine v around?
multiply by -1.
Yeah. So if we multiply this, make it a minus cosine u plus v, that'll give us sine u minus sine v, okay? So we multiplied the left side by -1 right there, okay? We just added a negative. Does that make any sense?
Yeah.
Okay.
Does it keep the U and V the same?
Yeah, it does. Yeah, it does. Okay, so what's my u gonna be here?
6,
My v,
10,
and what's u plus v?
16.
Yeah, so I'm gonna have negative cosine of 16 degrees.
So could you just like do it like that and then add a negative later?
Oh, yeah. Yeah, if you like doing it that way. Okay. You okay with this stuff? It's a lot better. It's more downhill, right? Alright, okay, half this problem got cut off. Let me look on the paper notes, see if it's any better. I'm guessing it's sine, cosine plus cosine sine. Okay, it's cut off on the paper. This is sine 37 plus cosine 19 plus cosine 37 sine 19. Okay. So looking at my identity sheet here, which one gives me a sine times cosine plus a cosine times sine. Yeah, sine u plus b.
Oh.
Okay, so what's my u here? 37, my b is 19. 37 plus 19 is 56. Okay, so this is going to be sine of 56 degrees. Okay, so that's how we do that. Okay. Yeah, you can. Can't go to that. I should get a bathroom pass. At Ignatius, we have a 60-pound sandbag. The kids have like wings sandbag.
Are you serious?
It was so Ignatius. Sorry, I gotta stop. I gotta stop talking about Ignatius. All right, good stuff. Okay, so for these, right, these are just a little trig proof. These are a little easier though, because it's a little easier to see which identity you should use. Sine of two things subtracted from each other. Right? We just got to look at our sheet, find it right here. Okay? Right, so it's a little easier to know which identity to start with. Okay? So my u here is x, my b is minus pi over 2, or sorry, it's just pi over 2, sorry. Pi over 2. Okay? That's 90 degrees in degrees. Okay? Okay, so then using my identity there, sign of the difference. So that's going to become sine x cosine pi over 2 minus cosine x sine pi over 2. All right. You guys see how I plugged everything into my formula? Alright, so what's cosine pi over 2? That's the same as the cosine of 90 degrees. So the cosine of 90, what's my coordinate at the top of my little crosshair circle thing?
0.
Yeah, it's going to be 0, 1. So cosine 90 degrees is 0. And this term goes away. Give it 0 here. Alright, and what's the sine of pi over 2, or the sine of 90 degrees? What's that y coordinate on top? The y coordinate on top of my little crosshair. So it's going to be minus cosine x. Okay. What's nice about the proofs is you can be 100% certain when you have. They give you the right answer. You just have to show them how you got it. Okay, that's kind of nice. Is this one after that? Worst Western literature ever. What?
It's the worst. So it's like the hardest Shakespeare.
Yeah, I've heard it's like one of the greatest pieces of literature ever. And part, like how do I do the second step?
Yes.
So, it was just I looked at my unit circle thing. I looked at my quadrantal angles. Look at that. Okay. That told me what that cosine pi over 2 is 0. So that term goes away because sine times 0 is 0. That told me that sine pi over 2 is 1. So it's just minus cosine x times 1. Yep. All right, let's do this next one. We want to prove this right here. How might you go about doing this? So looking at our sheet, there's no identities that have cotangent in them. Oh no. So what do we have to use? We're going to have to use the reciprocal. So if you did 1 over tangent, you could try that. You guys want to try that? Okay. I was going to do cosine over sine. I like doing that better, but you can do 1 over tangent, I'm sure. Oh, she didn't. Mrs. White didn't do it.
Oh,
Yeah, she didn't do it.
yeah, we don't have to do that.
Cross that one out. Yeah. It's all good. I'll just do it on my own for fun later. All right.
Do you have like a notepad and you write down, you go back and do stuff for fun?
Yeah. I've started doing more stuff for fun. If I'm gonna do it as my career, I probably gotta get used to it. It's better than sitting in a cubicle all day, having a midlife crisis at 45.
Are you gonna like solve an insane math problem? Or, like,
Yeah.
maybe like one of those math quizzes, like,
Oh yeah. They have like a lot of problems that you can get $1 million if you solve it. There's a lot of them. Yeah, it's called a Millennium Prize.
have you like done one?
No, it's so hard. There's a reason they haven't been solved. There's a reason like they're offering $1 million for solving these like math problems. All right, this next one. What do you think we do? All right, we have a sign of two things minus from each other and a sign of two things added. So we have formulas for those right here, right? Sign of u plus v and sign of u minus v. So let's just plug stuff in. Okay, I'm gonna use yours. Okay. So my u here is equal to x. My v is equal to y. So sine of x minus y, I'll color code these. Is the blue stuff simplifies to sine of x times cosine of y minus cosine of x times sine of y. Okay, and then we're gonna plus the orange stuff simplifies to sine x cosine y plus cosine x. Sorry. Okay. This might seem like a lot, but you just have to note that a lot of stuff matches. Many things match. So this minus cosine x sine y plus cosine x sine y. Do you guys see how these two are the same except they have different signs, SIGNs? These are the same thing, one's plus, one's minus, so those are going to cancel. Okay. And then these other two are a match. Okay. So just two of them. There you go. QED. Alright, so it's not as bad. Okay. Alright, any questions on this homework worksheet for our quiz that we have questions about? Yeah, sorry. What? Yeah, I have a little bit to do today, but not a ton.
Is 5-3 gonna be actually?
What?
5-3.
No, just 5-1 and 5-2. Sure, I'll have another.
You just like laugh like
You see it? Which I actually did.
I was with Ava and Sugar at Oxford.
Really? Yeah, I have like an 1,800 calorie meal full today in like 10 minutes. Yeah, let's do 5.3 for next time. I'll put it on school gym. What's that, Felice?
Oh, that's the same question.
Okay. Yeah, let's do 5.3 for next time. Yeah. Figure out all of them. That's so fun.
Yeah.
Gave it to me now.
To the basketball game.
Yeah, if you don't think you're gonna do it, I sure you want to like practice a little more. More than a blank one. Oh shoot, you guys need your test back? No. It wasn't, they weren't like horrible, they weren't great, but they weren't.
I didn't fail.
Yeah.
I was kind of surprised.
You got what you were shooting for, right?
I was shooting for an A-, so I got a C+.
gave so much partial credit. I was probably a little.
You were generous.
I was a little, maybe.
You gave a lot of partial credit.
I gave a lot of partial
Alright,
credit.
that raises my hopes.
Wait.
We got.
You guys can't walk out with these. Do not walk out with them.
I don't want to see how like Marshall.
Alright, do not walk out with these. Please hand them back.
How much is
Need to make this up. Please do so in a timely manner. I think we had 3 A's.
Oh, I got a bonus. I put a frowning face in the bonus box. I shouldn't do that.
Could have been better. Could have been worse.
Oh no. I put a little funny in the class. I put a little frowny guy.
I don't think so.
So I got like.
This one, I was talking to French.
Alright, so I'm coming
Alright, do not walk out with these. Please give them back to me on the way out. Alright.
You guys have to look at the
Yo, you were, you just
I think still
Oh my gosh. That's so
You guys saw
yeah.
that. You guys saw
That was like last year. I was like, I swear, okay,
earlier last week.
Hollis, I swear. Oh, no. I'm like,
Oh, I got it. I got it.
and I like flew off.
Wait, was this I right?
Oh,
my
In November.
Remember when I was in the
get out of the way out. Alright, get your test and get the way out, please.
I know you got, I know you got
Like the rain is so hard.
Alright guys, you can do it. Just come to me for help. We can have more reviews.
I tried to scan everything in the chat just to bury it.
I saw you try to take some stuff.
I was burying it, scanning out breaking it out.
Yo, I subbed for one of Hollis's house parties last year. I wish I would have known you guys.
Wait, it was me, Jake.
I remember Ben Branson was in there.
Wait, Ben Branson was in there.
I subbed for you last
Was my
year.
algebra class last year? No, yeah, my class was so fun last year. It was me, Ava, Jake, Jerron.
Were you guys the one that was like really high or the one that was like struggled?
No, we were actually pretty good.
She said she had a class last year where the average was like a 101.
Yeah,
They just like
probably
did
our class.
Like Allie, Jake did was ridiculous and all like
Jake and Jerron like taught themselves how to like do it. They were so good at it. They should have been in honors. They should have not.
so good. And then there's like
How do you take care of that? Yeah.
Can I come in?
After school today, I'm free till 4. Yeah, I'm free till 4.
So just review.
Yeah. Seems extra bright at the end of that. What? Seems extra bright at the end. Yeah, because I was a month. Really, natural light's a game changer, not gonna lie. You gotta open up those ones. What? You gotta open up those ones. Did I pass your test bag? Yes. Did you do well on it? Did you get 90? I got like a 90. Yeah, you're nice. Just bouncing up and down with your test scores, man. I gotta lock in on this one. I've been watching the videos. Watch the vids. walking. That was the first day. Oh, you weren't here. That's true. Yeah, we're gonna review period. So we're also having another quiz tomorrow. So when were you going last week? If you're on Thursday, I'll push it to today. I'll push it to tomorrow because that's what yeah, let the 7.3 homework. Okay, slow up to it. All right, get the 7.3 homework out. Okay, so that's like T. T needs a chair. You speed up, Ava. There's an empty seat here, right? Isn't that the empty? All right, 7.3 homework out, please. 7.3 homework out. 7.3 homework out. 7.3 homework. 7.3. Get that 7.3 homework out. Yo. Yeah, we have a quiz tomorrow.
We have lunch period.
No. I'm hungry too. I hit squat yesterday. I maxed out on squat. What's up?
What's your max?
It was actually a 10 rep max, so kind of not my max.
Our quiz is tomorrow.
Yeah. Sorry. I'm so sorry.
I thought it was today.
No, it's tomorrow. No, I did like 195 for 10 reps though. It's not bad. It's not terrible.
Is it just one?
7.1 through 7.3. Yeah.
Where do you live?
I go to the Monon Center in Carmel. Yo, I saw Pete Warner there. I saw Pete Warner leaving. Yeah. What up, Pete?
That's where I play basketball sometimes.
Really? Nice. Yeah, he was definitely pulling out. He has a black BMW, and I was like, dang, he's 23, drives a Beamer. He already has his own BMW. Then he feels scared. Oh shoot, I forgot to turn off the pre-cal lecture.